Hello everybody, this is still content from week 2, Grad Stats, University of Cincinnati. We have just discussed types of variables, so now let's apply what we've just learned. So we're going to go through the different variables in this data set of the Google Transparency Report, and you're going to think about for a few seconds what the kind of variable is, and I'll tell you what it is right after. So first variable, name of country. If you're thinking nominal and if you're thinking categorical and nominal, you're right because they're just names. You can't order them. Number of content removal requests made to Google. If you're thinking numerical and discrete, you're right because there is no, it's just a count. There's no number between 10 and 11. 224 and 225, so on and so forth. Percentage of content removal requests Google complied with. That's percentage. What kind of variable is that? This is a numerical and continuous variable because it makes sense to talk about, not just 100, 99%, 98%, but also 99.9%, 99.999%. So there is an infinite number of possibilities between two levels. Number of requests of user data, number of user data requests as part of a criminal investigation. That's again a count. So it is a numerical discrete. Next one is again, a percentage of user data requests that Google complied with. It's percentage again, so if you're thinking numerical, continuous, you're right. Next one, hemisphere, we talked about this one. That's a nominal, a categorical nominal variable. There is no ordering implied. How about the Human Development Index? If you're thinking categorical, you're right. And it is also ordinal because, you can say that high is more human development than, very high is more human development than high. Very good. So now let's move on to relationships between variables. So here on the x-axis, we have user data requests. And on the y-axis, we have user data compliance rate. And we're looking at the relationship between these two variables, and hopefully you can see that there is a connection between them, right? So when one changes, the other changes in a particular connected way. When two variables when two variables show some connection with one another, we call them associated variables. So they show a dependency between each other. We also say that they are correlated variables. And association or correlation can be described as positive or negative. When we say a positive relationship is when one particular variable goes up in value, the other variable also goes up in value, right? When one variable goes down in value, the other also goes down in value. A negative relationship is when one variable goes up and the other goes down. All right, so they move in reverse. They're connected, but they move in reverse directions. And they can also be linear or nonlinear. If two variables are not associated, they are said to be independent. So if I ask you to take a look at this graph, we already said that they show some connection between the two variables. Now think about it for a minute. Do you think this correlation or this association is positive or negative? If you're thinking positive, you're right, because as more data requests happen, more data compliance also happens, right? So the more user data requests to remove data occur, the more compliance also there is. But is this relationship linear or nonlinear? If you said nonlinear, you're right, because it's not well described by a line. It's more well described by a curve. types of study. Two primary kinds that you have to remember because it affects the type of inference that you can make. Let me get out of the way here. Observational. Data collection does not interfere with how data arises. It can be prospective, uses new data collected for the purposes of that particular study, or retrospective, uses past data. So if you go to a database to find out something, you're doing retrospective because this data is already there. And it can only establish association between variables. You're not interfering with anything, you're just observing. In experiment, however, you have random assignment of subjects to treatment, to particular interventions, and thus you interfere with how data arises. We'll see examples in a minute. And because of that interference, you get to establish some causal connections because you introduce a temporality in your experiment. Remember, causes come before consequence. That's one view of causality at least. So let's design a study. If you have this question, is there a relationship between working out and energy level? Now imagine you have a population, and in this population you have both individuals that work out regularly, and those are represented in yellow, and you also have individuals that don't work out at all. So what would an observational study look like? I would not interfere with anything. I would just go ahead and recruit participants that work out regularly, put them in a group, and recruit participants that don't work out regularly. This is already natural of their daily lives. That's why I'm saying I'm not interfering. I am not telling people to exercise or not exercise. They already do that. And then I'll measure the energy level. I'll come up with a measure of energy level of these two groups and compare. That's an observational study. And that's the one that you can only establish correlation between variables, not causation. All right? Because it may be the case that high energy level that the person already has is what makes them work out. You cannot say that workout leads to higher energy level. If you want to make that kind of causal connection, you need more than an observational study, because here we're just establishing a correlation. So what would an experimental study in this case look like? Well, you would get only individuals that don't work out to begin with. You're going to come to the population and just sample individuals randomly, individuals that do not work out, right? So I just get those. And then I'm going to do some random assignment to different groups. So random sampling is when I go from the population to the study. And random assignment is when I go to my sample to the different groups in my study. Let's see how this works. I have a sample that with only people that don't work out. And then as an experimenter, I randomly select some people in this original sample and assign a workout to them. I actually tell them, now from now on, you're going to be engaged in an exercise program, this and that way, 3 times a week with that intensity, blah, blah, blah. In the other group, I say, well, you can just carry on as is. Please do not, if you get engaged in activity, let us know. But as, you know, move on as normal. Then time goes by, and then I measure the energy level, right? If there's difference between groups now, it cannot be because high energy level leads to activity, because I was the one who introduced the activity, and then I measure the energy level after. So if one group has more than the other, the only difference between them is the introduction of activity in one of the groups. Some principles of experimental design. We have control. We compare treatment of interest to a control group. And treatment does not need to be medical treatment. It can be whatever kind of treatment you can, whatever kind of intervention you can think about. You have to randomize. You randomly assign subjects to treatment. You have to be able to replicate. So that means you need to collect sufficiently large sample or replicate the entire study. in order to establish consistency. And you have block. You block for variables known or suspect to affect the outcome. So let's look at blocking, because we didn't talk about that yet. Think about this one question. Do energy gels help athletes run faster? So here is our population of runners, all individuals that run. And then we have in yellow the amateur runners, and in blue the pro runners. So I can then sample from this population, and I can do perhaps stratified sampling, so I'm getting an equal number of pro athletes and amateur athletes or runners. So that's my sample. And then, because being amateur or pro could be a confounding variable affecting the relationship between the effect of energy gels and speed, what I do, because of course we expect pro athletes to run faster on average, let's say. So we need to block to guarantee that we're controlling for this, right? So what we do, we get these people, and we get amateurs in one group and pro in another group. And then I randomize. I randomize the amateurs in a group that receives gel and a group that don't receive gel. And I do the same thing. Let me get out of the way again. I do the same thing for the pro group. I assign one group to receive gel, and I assign another one not to receive gel. All right? So check your understanding here. Think a bit and try to answer this question. Stop the video if you need to. What is the difference between stratifying and blocking? So stratifying is a move from the population to the sample. I have to guarantee that I'm sampling equally from amateurs and from pros, so that I get a sample that has an equal number of amateur and pro runners. Now, blocking is when once I have the sample, I create one group, one set, I separate them up, and I get one set of only amateurs and one set of only pros, so that I can control for the effect of the amount of running, or the professionalism in running, and control for that effect in my research question. So stratifying is a sampling strategy from population to sample, and blocking is an assignment strategy from sample to groups. On the roles of variables in our experiments. Variables can have a variety of roles. They can be response variables, also known as dependent variables or outcome variables, and these capture the phenomenon we're interested in. So for instance, in the prior study, we're interested in knowing whether a particular intervention, a particular diet, interferes in running speed. So I'm interested in running speed. How can I get running speed? How can I get people to run faster? What are the kinds of things that I can do? So that's the response variable. The thing that explains that response is the explanatory variable, also known as independent variable or factors. Don't blame me for all of these terminologies, but those are synonyms, and they're defined by conditions we can impose in our experimental units. So the gel is an explanatory variable because I can manipulate. I'll give gel to some of them and not to others. And blocking variables are characteristics that experimental units or people or countries come with that we would like to control for. So in this case, the case of the prior example, we have the level of professionalism in running, whether you are professional or not, interfering with the effect of the gel. So we decide to block the participants so we can look at the effect separately in athletes and in pro athletes and amateur athletes. We're almost done, guys. Hang in there. We're going to come back only to try and apply these concepts to a particular study to make sure you understood. All right, see you in a bit.